Okay, so ideal gas law questions, or questions that look like ideal gas law questions, can pop up in the multiple choice questions. Normally, you'd get 5 marks, pretty much, for a ideal gas law question where you have to do something before or afterwards. But you'd at least get 3 for converting units, rearranging the equation, substituting in. So how can it pop up for just 1 mark in the multiple choice questions? Well, if we look at this question here, you've got 30 centimeters cubed of xenon, 20 centimeters cubed of fluorine, they're reacting to make XeF2. At this point, you're also thinking, I don't have enough information for anything here. I know that the ideal gas law is PV equals nRT. I've got a volume and I've got nothing else. I also know that R is 8.31, but it's not going to be in the question. So how are you supposed to do this? Well, the important thing is assume that the temperature and the pressure remain constant. So pressure and temperature aren't changing. We can get rid of them out of the equation. You also know that R is a constant, so that doesn't change. And now we've got this, which really we should write as volume, is proportional to the number of moles. So now we can treat volume and moles, well, we can treat volume like we would normally treat moles. So we've got the equation Xe plus F2 goes to XeF2, and everything's a gas. So rather than saying we've got a certain number of moles of xenon, let's just say we've got 30 xenons. Fluorine, we've got 20. They're going to react together. Now we've got a limiting reagents question. See, this was just a limiting reagents question hiding as an ideal gas law. So I've got 30 xenons, 20 fluorines. Which one's going to get used up first? The ratio is 1 to 1, so they get used up at the same rate, which means I'm going to run out of fluorine first. And that's going to go down by minus 20 to make 0. Let's do initial, change, and end. Xenon, it's a 1 to 1 ratio, so it's also going to go down by minus 20. So it goes down the same as fluorine. 30 take away 20 gives me 10. On the other side, I start with no XeF2. Because I'm on the product, this time I'm going to go up by 20, because again, it's a 1 to 1 ratio. So I've ended up with 20. What's the final volume of gas after this reaction is complete? Well, I've got my 20 here, and I've also got 10 of the xenon left over. So my final answer has to be 30. Don't forget the gas you're left over with from the one that is the one in excess, which is the xenon. But because everything else cancels out in the equation, you can just treat volume like you would moles. Here's another example of that, but a little bit trickier. So I've got nitrogen plus fluorine going to NF3. I've got 30 nitrogens, 60 fluorines. Again, it tells you it's at constant temperature and pressure, so everything cancels out. I can just treat volume like I would moles. Don't know why I'm including the gas symbols this time, just for fun. If you want, you can times everything in the equation by 2 just to get rid of the fractions, but you don't really need to. Okay. Ugh. So the nitrogen, I'm starting off with 30, and the fluorine, I'm starting off with 60, NF3, I'm starting off with 0. So now, which one's going to get used up first? This was a trickier question because we've got the coefficients in front of the nitrogen and the fluorine. So we've got half of a nitrogen and 3/2 of a fluorine. That means fluorine is basically 3 times bigger than the nitrogen. I've got 3 more times, don't know why I can't put this into a sentence, 3 times as much fluorine as I've got nitrogen. There we go. So the fluorine has to get used up 3 times quicker. If it gets used up 3 times quicker, I need at least 3 times more of it. 60 is not 3 times bigger than 30. And because 60 is not 3 times bigger than 30, fluorine has to be my limiting reagent. It's going to get used up first. And then this one is going to get used up 60 divided by 3 because it gets used up 3 times smaller. Again, if you just rearrange, if you just doubled everything so it was 1, 3, 2, you'd still get this same 1:3 ratio. 60 divided by 3 is 20, 30 take away 20 is just going to be 10. Now, this is where your maths gets a little bit trickier. On this side, we're going to have to go up plus 60. But then what do we have to times or divide it by? Well, we're going from 3 halves to just 1. So divide by what you, times by what you're going to, which is 1, divide by what you're coming from, and dividing by 3 halves is the same as timesing by 2/3. So I've got 40 centimeters cubed of my NF3. So how much, or what's the volume of gas mixture after the reaction? That should also be another clue that if you're just including one of these, you're wrong. So is it 40 plus 10 gives you 50, and that is the answer. So it's just another limiting reagents question that looks like an ideal gas law question. Enjoy them, they're fun.